The black hole. That shouldn't be moving space is not empty, not really. We're taught that from an early age, vast darkness, scattered stars, distances so enormous they stop meaning anything to a human mind. But go deep enough into that darkness and you start finding things that refuse to sit still. Objects that are not supposed to move at all suddenly do. And when something with the mass of 10 million suns starts racing through the void at 1,000 kilometers every second, leaving behind a wake that stretches for nearly 200,000 light years, the universe is telling us something we clearly did not understand. This is the story of that object. And by the end of it, you'll understand why a handful of astronomers looked at a single photograph and knew almost instantly that they were looking at something that had never been documented in the history of astronomy. For more than 3 decades, the Hubble Space Telescope has been quietly photographing the cosmos, sending back images of galaxies so distant that their light left home before the Earth had continents in their current positions. Most of what Hubble captures confirms what we already suspect. Occasionally, though, it captures something that fits no existing category at all. That happened in 2023, when a team of astronomers pointing Hubble at a small, unremarkable-looking distant galaxy noticed a feature in the data that made no immediate sense. A thin, luminous line of stars cutting across space like it had been drawn there on purpose. It wasn't a small feature. This line stretched for nearly 200,000 light years. To put that into perspective, our own Milky Way, home to roughly 200 billion stars, spans about 100,000 light years from edge to edge. What Hubble had photographed was almost twice the length of our entire galaxy, compressed into a narrow, glowing thread of newborn blue stars, millions of them, carrying a combined mass equivalent to roughly 100 million suns. And it was straight, not roughly straight, straight in a way that immediately raised questions because nature rarely draws with a ruler. When Peter Van Dam, the astronomer from Yale University who led the initial analysis, looked at the image, he said something that carries real weight in a field built on decades of precedent. That nothing like this had ever been observed anywhere in the universe. That is not a sentence astronomers use casually. We have watched stars explode. We have watched galaxies collide in slow, billion-year embraces. We have traced the birth and death of stars across cosmic time, and still, nobody had ever seen a perfectly straight line of newly formed stars stretching across 200,000 light-years of open space. The obvious question followed immediately. What could possibly draw a line like that? In science, when you encounter something inexplicable, you don't guess wildly. You build hypotheses, testable ideas, and you eliminate them one at a time. The first explanation was the simplest. Maybe this wasn't a line at all. Maybe it was an ordinary galaxy, seen edge-on, so thin and flat from our viewing angle that it only appeared as a narrow strip, the same way a sheet of paper looks like nothing more than a line when you view it from the side instead of face-on. It was a reasonable idea. But when researchers examined the light coming from the stars more closely, the theory collapsed. In a normal galaxy, stars span a huge range of ages, some newborn, some billions of years old, producing a mix of colors. Every single star in this line, however, was young. Every one of them was blue, the signature of recent formation. That uniformity was the first sign that something unusual was happening. There was a second clue, and it came from the very front of the line, the leading edge, the point it appeared to be heading toward. The light there carried a very specific signature: superheated oxygen, stripped of its electrons by extraordinary amounts of energy. That kind of ionization doesn't happen casually. It requires violent, high-energy conditions, the kind you don't stumble across accidentally. The edge-on galaxy theory was dropped. The second hypothesis involved jets, the high-speed streams of radiation and particles that some galaxies fire outward, sometimes at velocities approaching the speed of light. When these jets slam into surrounding clouds of gas, they can trigger those clouds to collapse and ignite new stars. It's not a hypothetical mechanism. It had already been observed elsewhere, in objects like Minkowski's object and the galaxy Centaurus A. So maybe a jet from a nearby galaxy had carved this trail. But the physics didn't cooperate. Jets widen as they travel away from their source, and the most intense activity typically occurs close to where the jet originates. This line did the opposite. It was widest near the parent galaxy and narrowed sharply toward the tip. And the most energetic activity, that superheated, stripped oxygen, was happening at the far end, not the near one. Everything about the jet explanation ran backward. That idea was dropped too. By this point, the researchers were left with an idea that, on paper, sounded almost too strange to say out loud. What if this line wasn't caused by a jet, and wasn't the edge of a galaxy, but was instead the wake of something enormous physically moving through space at tremendous speed? What if it was the trail of a runaway black hole? The concept of a black hole flying free through the cosmos wasn't new. It had existed as pure theory since 1983, when physicist Michael Fitchett worked out the mathematics of what happens when two black holes merge. That merger isn't a smooth, symmetrical event. It releases energy in the form of gravitational waves, and crucially, those waves don't radiate evenly in every direction. They come out lopsided. And an uneven release of energy always produces a recoil, the same basic principle behind a gun kicking back into your shoulder when a bullet fires forward. Fitchett's equations showed that a sufficiently asymmetric merger could kick the newly combined black hole hard enough to send it flying out of its home galaxy entirely, potentially reaching speeds of hundreds or even thousands of kilometers per second. For 40 years, that remained a striking idea confined to chalkboards and simulations. Nobody had ever actually seen one. Then came the Hubble image of 2023, and with it, a question nobody could ignore. To answer it properly, the team needed a sharper instrument. That opportunity arrived in December 2025, when astronomers turned the James Webb Space Telescope toward the line. Webb doesn't just take prettier pictures than Hubble. It resolves far finer detail, the equivalent of trading ordinary glasses for a far stronger prescription. And what it revealed settled the question. At the very tip of the trail, Webb detected a bow shock, a structure familiar to anyone who has watched rain scatter off the front of a moving car or watched a boat's hull push water into a wave ahead of it. Whenever something moves fast enough through a surrounding medium, that medium gets shoved violently out of the way, compressed, heated. Here, the medium was interstellar gas and dust, and the object plowing through it was almost incomprehensibly massive. The data confirmed a black hole with a mass of at least 10 million times that of our Sun, moving through space at roughly 1,000 kilometers per second. Fast enough that if it were to pass anywhere near our solar system, it would come and go before we ever managed to notice it. The team gave it a name, Runaway Black Hole 1, or RBH1. For the first time, humanity had direct observational proof that a supermassive black hole could be ejected from its galaxy and go wandering through the universe alone. But that raised an uncomfortable contradiction. We think of black holes as engines of destruction, objects that shred stars, swallow planets, and trap even light itself. So how could one possibly be responsible for creating millions of new stars? The answer turns out to be one of the more elegant mechanisms in modern astrophysics. As RBH1 tears through space, its gravity compresses the gas and dust directly in front of it, and the resulting shockwave heats that material intensely. As the black hole continues forward, this heated, compressed gas trails behind it and begins to cool, mixing with the surrounding interstellar medium. And cooling gas doesn't stay smooth and diffuse. Gravity takes over, pulling matter into clumps. Those clumps grow denser as they draw in more material, and denser clumps pull even harder in a runaway process that eventually reaches a tipping point, enough density and pressure at the core to ignite nuclear fusion. A star is born, then another, then millions more, strung out behind the black hole like sparks trailing off a comet. The very force that should be annihilating everything in its path is instead seeding the galaxy around it with new suns. Knowing what RBH1 was still left the deeper question unanswered. Where did it come from? The trail itself held the answer because a wake, like a set of footprints, can be followed backward. Astronomers traced the line of stars to its point of origin and found a galaxy system nicknamed the Cosmic Owl, sometimes called the Infinity Galaxy, located somewhere between 7.5 and 9 billion light-years away. Through a telescope, it resembles a pair of wide eyes and a pointed beak, because it isn't one galaxy at all, but two, fused together after a collision. What made this collision extraordinary wasn't just that two galaxies merged, galactic mergers happen throughout the universe, but that both galaxies involved were ring galaxies, among the rarest structures known to exist, making up roughly 0.01% of all cataloged galaxies, with only a few hundred confirmed examples anywhere. A ring galaxy forms only when one galaxy passes almost precisely through the center of another, a cosmic version of throwing a dart and landing at dead center on the very first attempt, virtually impossible by chance. One such collision is already a statistical anomaly. The Cosmic Owl involved two. When these two ring galaxies met, it wasn't a gentle graze. It was a slow-motion collision lasting millions of years, closer to two freight trains meeting head-on than any gentle cosmic dance. At the heart of each galaxy sat a supermassive black hole, as is typical for large galaxies. Rather than colliding instantly, the two black holes spiraled inward toward each other over time, drawn by mutual gravity, until they finally merged into one. And just as Fitchett's 1983 equations predicted, that merger released gravitational energy asymmetrically, producing a violent recoil, a kick powerful enough to hurl the newly formed black hole entirely out of its host galaxy at approximately 1,000 kilometers per second. That launch is where RBH-1's journey began, and it has been traveling and building stars in its wake ever since. This discovery forces a real reconsideration of something astronomers had long treated as settled, the assumption that every large galaxy's central black hole is a permanent fixture, anchoring that galaxy for the rest of its existence. RBH-1 proves that assumption wrong. Supermassive black holes can be expelled entirely, sent drifting through intergalactic space, and if it happened once, there is no reason to think it's an isolated event. Galaxy mergers are common across the universe, and wherever galaxies merge, their central black holes eventually merge too, meaning the same recoil mechanism responsible for RBH-1's ejection should statistically be happening elsewhere. Astronomers didn't have to look long to find candidates. One is a galaxy cataloged as J2245 plus 2456, roughly 228 million light-years away, where the central black hole appears to be moving at a distinctly different velocity than the rest of the galaxy surrounding it. As if it doesn't quite belong, the signature you would expect from a black hole mid-ejection. Another is Able 2261, a massive galaxy cluster whose central galaxy should host one of the largest supermassive black holes known, somewhere between 3 and 100 billion solar masses. Astronomers have looked for it. It isn't there. One leading explanation is that it, too, was launched out of its galaxy by a violent merger, and is now somewhere out in the darkness, its trail simply not yet found. Finding more of these wandering giants is about to get significantly easier. The Euclid Space Telescope, along with the upcoming Nancy Grace Roman Space Telescope, designed to capture Hubble-level clarity across vastly larger swaths of sky, will dramatically expand the search area. Meanwhile, astronomers are increasingly turning to machine learning, training algorithms to sift through enormous volumes of telescope data and flag the faint, thin trails and bow-shock signatures that are easy for the human eye to miss entirely. If these tools succeed, they could reveal dozens or even hundreds of runaway black holes, transforming a single confirmed case into a genuine population that can be studied statistically. That population would answer questions astronomers had never previously thought to ask. How often does this happen over cosmic history? What fraction of supermassive black holes eventually get ejected from their home galaxies? And what happens to a galaxy once its central black hole disappears? Does it destabilize? Does its structure change? Does star formation across the whole system shift? When researchers went back to examine the cosmic owl itself, they found it looking disturbed, disrupted, consistent with having recently lost the anchor at its center. That single observation opened a much larger search through archival data for other galaxies that looked, in some subtle way, wrong, missing a black hole that theory says should be there. There's also a harder question sitting underneath all of this. As RBH-1 barrels forward at 1,000 kilometers per second, it isn't only compressing gas into new stars, it's also tearing through anything already in its path. Existing stars caught directly in its trajectory would be destroyed. It is, quite literally, simultaneously creating and demolishing, building new suns behind it, while obliterating whatever lies ahead. Some scientists argue this barely matters on a cosmic scale, a single object's effect diluted across the unimaginable vastness of the universe. Others point out that every star lost is a star that might have hosted planets, might have hosted the conditions for life, meaning the balance between creation and destruction here is not a trivial detail, but a genuinely open scientific question. And there is a wider possibility scientists are only beginning to model, that this may not be a one-time event for any given black hole. Simulations suggest a runaway black hole could eventually drift into another galaxy entirely, merge with that galaxy's own central black hole, and potentially get kicked out again, restarting the cycle. Over billions of years, this would produce not a single wandering giant, but a population of cosmic nomads repeatedly ejected, repeatedly merging, repeatedly reshaping the galaxies they pass through, each one potentially leaving its own trail of newborn stars stitched across the darkness. If even a fraction of that turns out to be accurate, the sky may already be quietly marked with these lines, faint enough that we've simply never known to look for them until now. What makes RBH-1 matter isn't really the object itself, remarkable as it is. It's what it reveals about how much of the universe still operates outside our assumptions. We built entire models of galaxy formation around the idea that a central black hole is a fixed, permanent feature. That model just failed its first real test. And it failed in the most unexpected way possible. Not by revealing more destruction, but by revealing creation hidden inside violence. Millions of stars strung like lights across 200,000 light-years of space, brought into existence by the very object that should have been erasing everything in its path. The universe has always been described as a place of both birth and annihilation. RBH-1 is a reminder that those two forces aren't always opposites. Sometimes they're the same event, viewed from different angles. A black hole, flying alone through the void for what may be billions of years, quietly seeding the space behind it with the raw material for future stars, future planets, future possibilities we can't yet imagine. We only found this one because Hubble happened to catch it at the right moment, and because a small team of scientists refused to dismiss something in the data that didn't fit any known explanation. If one runaway black hole was hiding in plain sight this whole time, it's worth asking seriously what else is out there that we simply haven't learned to recognize yet. If stories like this make you look at the night sky a little differently, consider subscribing for more science documentaries exploring the discoveries reshaping how we understand the universe. And let us know in the comments what cosmic mystery you'd want explored next.